In this video, we'll look at problems that initially look really confusing, but if you can remove the confusing parts for a little while you deal with factoring, you can actually make a very hard problem very simple. And I'll show you the dummy variable or substitution method, but eventually you may be able to just see the structure of the expression and factor without needing the dummy variable. In example 1, you see a trinomial with the highest degree of 4. You usually see trinomials that have an x squared at the beginning, then an x term, and then a term without an x. But we haven't really dealt with trinomials that have an x to the 4th. To make my problem simpler, I'm going to use the fact that I know that x squared is actually x to the 4th. We could proceed without using a dummy variable, but by defining a to be x squared, I can prevent a lot of mistakes that can otherwise occur. So now I'll just rewrite my equation with the dummy variable instead. So I now have 3a squared minus 17a minus 6. And now I have a fairly easy quadratic trinomial to factor. I start by multiplying 3 and 6. So 3 times negative 6, so negative 18. And then think of two factors of negative 18 that will add up to negative 17. That's going to be negative 18 and positive 1. So now I rewrite my trinomial 3a squared minus 18a plus 1a minus 6. Now it's time to group and pull out the GCF. So 3a minus 6 plus 1a minus 6. And rewrite, I have a minus 6, 3a plus 1. But now the really important part is going to be to take this x squared and put it back into the problem. So now we'll have x squared everywhere that we used to have an a. Now we could have just gone along without the a. So everywhere you see an a, I could have replaced it with an x squared. But I feel like it gets really risky in this area, and people tend to lose a square, and then it won't group properly, and bad things happen. So that's why I like to use the dummy variable. On sort of a side note, you may wonder, are we finished factoring? And we actually are. 3x squared plus 1 doesn't factor any further, and x squared minus 6 doesn't factor any further either because 6 is not a perfect square. So these numbers should look pretty familiar to you, the coefficients of 3, negative 16, and negative 6. They're actually the same coefficients as before, and I did that on purpose to really emphasize the structure of this problem. That at its root, this problem is exactly the same as the previous problem, except I'm just going to use a different dummy variable. So this time I'm going to use the fact that x to the 3rd squared is x to the 6th. So I'm going to use my a as x to the 3rd. So now I'll do 3a minus 17a, 3a squared minus 17a minus 6. Now we've already done that problem out in the previous example, and I know it factors to 3a plus 1 and then a minus 6. And now though, when I go to put my x's back in, I'll have 3x to the 3rd plus 1 times x to the 3rd minus 6. So all that was really different is we had a different exponent on our answer, different exponents in our question. Again, could we factor this further? Well, 3x to the 3rd is actually not a perfect cube because 3 isn't, so we can't factor that. And then 6 is also not a perfect cube, so I couldn't factor that using difference of cubes. All right, one more example with these same coefficients, the 3, the negative 16, and the negative 6. Now, if you really wanted to put yourself through a lot of work, you could expand this out, distribute here, combine like terms, and then try to factor. Or you could realize that at its root, this is exactly the same question as the previous two problems. I'm now, though, going to use my dummy variable as a is x plus 4. So now I have 3a squared minus 17a minus 6. At this point, I hope we know that this factors to 3a plus 1 times a minus 6. Now this part's a little tricky. I have to put my x back in. So I'm going to have 3, and then I'll put parentheses for my a, x plus 4 plus 1, and then x plus 4 minus 6. Now those double parentheses didn't matter as much in the second term, the second factor, but in the first factor it's really important because I have to distribute here. So I'll have 3x plus 12 plus 1, and then x plus 4 minus 6, which I can simplify to 3x plus 13, and then x minus 2. So it initially looked like a very tricky problem, but because we knew how to solve this more simple problem, we were able to factor it very quickly. If you really want to torture yourself, try expanding this original problem out, and I bet you get it to factor to what we get at the end. Finally, a different problem. You'll notice this problem has a very different structure than the first three. We only have two terms. When I see two terms, I think difference of squares or sum or difference of cubes. Well, 25 is a square and 4 is a square, so I think I want to use the difference of squares. I'm going to use the fact that x to the 5th squared is x to the 10th. So I'll say a is x to the 5th. If you're wondering how I keep coming up with these x's, these a's so quickly, is that if I'm trying to make it have the structure of a quadratic, I'm going to divide this exponent by 2. And the reason I'll do that is that's taking the square root. So I want to take the square root. So let's have 4a squared minus 25. You know difference of squares factors to 2a plus 5, 2a minus 5. And then I go and put my x back in. So I'll have 2x to the 5th plus 5 times 2x to the 5th minus 5. And you're going to leave it like that. We don't know how to factor degree 5. All right, one last example, a pretty tricky one. It's actually example 5, not example 6, so don't think you've missed something. Here, again, I see a binomial, so I want to think difference of squares or difference of cubes or sum of cubes, so plus or minus. 8, however, though, is not a square. 125 is not a square, but I know that they are cubes. So I don't want to use the square. I think I'll use the cube, and I think I'll use the sum of cubes. Now this time I'd actually need to use two dummy variables because as you can see, neither of our exponents are a 3. But we're lucky both of them will divide nicely by 3. So I'm going to say a is going to be, let's say, x to the 4th, and I'll let b be y squared. That way, a to the 3rd will be x to the 12th, and b to the 3rd will be y to the 6th, which is what we had in our original problem. So I'll rewrite as a 8a to the 3rd plus 125 b to the 3rd. And then I'll factor that using my formula. So I'll have 2a plus 5b, because the cube root of 8 is 2. Cube root of 125 is 5. And then 4a squared plus 20ab plus 5, whoops, not 5, 25b squared. All right, so now this is where we need to be careful as we put our, our x and our y back in. So every time I see an A, I'm going to put x to the fourth. Every time I see a B, I'll put y squared. So I'll have 2x to the fourth plus 5y squared times 4. Now I have x to the fourth squared, and I'll simplify that later, plus 20x to the fourth y squared plus 25y squared squared. And I'll simplify that now. So 2x to the fourth plus 5y squared times 4x to the eighth plus 20x to the fourth y squared plus 25y to the fourth. And that was a nasty problem, but I hope it helped.